SpaceX, led by Elon Musk, is pioneering the construction of a colossal rocket factory along the Texas coastline. This groundbreaking endeavor marks the first instance of orbital rockets being mass-produced on an assembly line. This visionary project is aptly dubbed the Starfactory. But why does SpaceX require such a massive facility, and how do they plan to operate it? Stay tuned to find out. As SpaceX approaches a new chapter, marked by the maturation of its Starship rocket, after 4 years of rigorous development, testing, and occasional setbacks, the company finds itself at a pivotal juncture. The evolution of Starship into a fully operational Super Heavy launch vehicle necessitates a corresponding evolution in the processes and infrastructure surrounding its manufacturing and deployment. A decade ago, when SpaceX first set foot in Boca Chica Village, it was a barren landscape characterized by sandy terrain, coastal waters, sparse vegetation, and a few mid-century bungalow houses. The village seemed frozen in time, remnants of a failed attempt to establish a town that had been abandoned in the 1960s and largely forgotten. It was against this backdrop that Elon Musk and SpaceX embarked on their ambitious venture. In those developing stages, SpaceX's approach to production mirrored their surroundings: rough, makeshift, and marked by trial and error. The initial Starship prototypes appeared crudely assembled, reflecting the company's ethos of constant experimentation and improvement. However, as time progressed, so did their facilities. What began with modest tents, or sprung structures, as engineers affectionately dubbed them, soon evolved into larger, more sophisticated structures. The introduction of vertical shelters allowed for the stacking of rockets without fear of toppling in the wind. From humble beginnings in the low bay to the grandeur of the high bay, SpaceX's production site underwent a remarkable transformation. Correspondingly, the quality of their rockets improved exponentially. What once resembled a flying water tank gradually morphed into something resembling a flying grain silo, before finally achieving the appearance and functionality of a true rocket. This journey was not without its setbacks, however. Explosions became a defining feature of the middle era of Starbase, spanning from 2020 to 2021, as each failure provided valuable lessons for future endeavors. The past year has ushered in a wave of transformation at Starbase, with a notable shift in how starships meet their fiery fate. Now, explosions occur mid-air rather than upon impact with the ground. Yet, while the rocket designs have undergone significant evolution, perhaps the most striking changes have unfolded within the production site itself. In late January 2024, the removal of the final production tent at Starbase signaled the end of an era. In its place, the Starfactory emerged swiftly, symbolizing SpaceX's rapid progress toward establishing a permanent manufacturing hub for starships. This step is crucial to SpaceX's grand vision of colonizing Mars, which demands a substantial fleet of starships. Gwynne Shotwell, president of SpaceX, set ambitious production targets, envisioning the construction of one new Starship upper stage every day by 2022. By 2023, the goal expanded to include dozens, if not hundreds, of Starship launches daily. Achieving such unprecedented objectives requires the Starbase teams to tackle the monumental challenge of mass-producing orbital rockets, a feat never before attempted. Comparatively, the Soviet Union came closest to achieving a similar production scale, producing around 60 Soyuz rockets annually in the mid-1970s. In contrast, NASA struggles to manufacture even one Space Launch System (SLS) rocket per year, with each launch costing approximately $4 billion. Given these obstacles, the question arises: how does SpaceX plan to accomplish such ambitious production rates from a solitary facility in the remote Texas desert? To understand the inner workings of a Starship factory, we can examine SpaceX's construction process thus far. Over the years, SpaceX has erected a series of vertical assembly buildings at Starbase, starting with the low bay, mid bay, and high bay, and recently expanding into the mega bay. The low bay and mid bay have already been demolished to make way for the Starfactory construction, while a second mega bay has just been completed. The mega bay represents the future of Starship construction, with one building dedicated to orbital ship stages and the second to super heavy boosters. These structures serve as assembly facilities where rocket stages are constructed by stacking prefabricated ring sections and welding them together. Elon Musk has explained that SpaceX has continuously widened these buildings over time to accommodate more working stations within each bay. This allows for the simultaneous assembly of multiple ships and boosters. In a wide-angle photo shared by SpaceX, 3 full-sized boosters are seen on engine installation stands, while 2 partially assembled boosters are stored on the sides, awaiting their turn. Each megabay has enough room to hold a total of 5 rockets, with up to 3 being worked on simultaneously. These tall buildings function as general assembly areas, while the lower areas handle more intricate manufacturing processes. In the early stages of Starbase, SpaceX technicians operated out of 3 long tents serving as their primary production lines. However, these tents have recently been replaced as the permanent factory structure continues to expand. While setting up rockets in tents may sound unconventional, it mirrors Tesla's approach to building the Model 3 and Model Y vehicles. Instead of fitting into existing factory spaces, Tesla set up large tents in the parking lot to start from scratch. This strategy allowed them to incorporate new manufacturing techniques, such as the GigaPress casting machine, which was too large to be integrated into existing factory floors. SpaceX's manufacturing process begins with the receipt of raw materials, including giant rolls of 304L stainless steel. These rolls are cut to length, formed into rings, and welded to create the straight sides of the ship and booster. For curved components like the nose cone and interior domes, forming the tops and bottoms of fuel tanks, SpaceX receives panels of stamped and stretch-formed stainless steel, which are welded together. The original 3 tents represented 3 streams of Starship components being manufactured in parallel, one for the top, middle, and bottom sections of the Starship. Each tent has a specific focus, with one dedicated to Raptor engines and the lower thrust section, another for ring sections and domes comprising the body and fuel tanks, and the third for producing nose cones. Nose cones are constructed from long pieces of stretch-formed stainless steel, welded together along vertical lines and fitted with heat shields before completion. This process enables SpaceX to manufacture key segments of the ship and booster simultaneously on the ground before final assembly in the mega bay. Once at the mega bay, the segments are stacked, welded, and undergo final touches, including the installation of engines, wings, grid fins, and actuators. Based on current observations, it seems that SpaceX is likely maintaining a similar manufacturing process within the new Starfactory building. However, this is only speculation, as the solid walls of the factory provide a level of privacy not previously seen around Starbase. Previously, it was relatively easy for onlookers to observe ring stacking in the open tents, but this era has now ended. The completed sections of the Starfactory building currently resemble an L shape, but are evolving into more of a U shape as a new factory segment is erected along the highway edge. The Starfactory's footprint is estimated to be around 800 feet in length and width, with a roofline reaching 60 feet in height. This configuration will streamline the manufacturing process by providing a continuous production floor, unlike the 3 separate tents. With 2 to 3 times more covered floor space and increased vertical space, SpaceX could potentially create taller segments, reducing the number of sections to be stacked in the assembly bay. The final layout of the Starfactory will likely be more or less square in shape, offering approximately 5 times more total production space compared to the initial setup with the 3 primary tents. With the primary tents cleared out, the final foundation of the Starfactory is being rapidly constructed. This massive production space will enable SpaceX to work on multiple new rockets simultaneously, prefabricating segments that can be easily stacked and finished before transportation to the launch site. This high production volume is essential for SpaceX to achieve Elon's ambitious vision for Starship. Starship's significance extends beyond merely replacing SpaceX's existing fleet, including the Falcon 9, Falcon Heavy, and Dragon capsule. It also plays a pivotal role as the primary vehicle for NASA's Artemis moon landing program. Moreover, Starship serves as the linchpin in Elon Musk's mission to establish a self-sustaining city on Mars. In this grand vision, the Starfactory is indispensable, serving as the key facility for manufacturing and producing the numerous starships required to achieve these ambitious goals. What do you think? Can SpaceX really achieve its goal of building a new Starship every day? Let us know in the comments below.